Hello, we are Group 1, Team Uncertainty. My name is Joshua Mogan.
And I'm Gavin Deersman.
I'm Brian Sosa.
I'm Ryan Grzinski. I'll be going over the goal and design requirements for this project. The goal of this project is to analyze the results obtained by the calibration and error analysis associated with an experimental procedure that involves taking measurements on temperature and distance. The design requirements to reach our goal for this project include a temperature measurement system, a distance measurement system, and a water depth system. Each system has its own requirements. They all have a range and display requirement. The temperature has an additional resolution requirement, and the distance system has an additional medium of measurement requirement. These, in coordination with our Arduino, will yield the results necessary to calibrate our systems and perform error analysis. For the strategy of our project, we initially go with each group member going through the demonstrative lessons and then a delegation of tasks among the group members. From there, it was up to each group member to complete whatever tasks they could while supporting the one group member who was in possession of the Arduino kit.
All right, I'm Gavin. I was in charge of the Arduino kit, and here are the design steps. So there's four main circuits that were used in our measurement system. All of these were gone over in the tutorials for the Arduino projects. We have a servo, which is connected to the Uno. We have a water level sensor, a ultrasonic sensor, and an LCD temperature sensor, or LCD screen with temperature sensor, all hooked up to Arduino Uno and then coded on the program. So we had a few problems with some of this. The servo using as a dial measurement system, it only has a rotation of 180 degrees, so that only half of our circle is being used for measurements. And you can also see our temperature sensor being used on the image. It's showing 25.45 degrees Celsius right now on the LCD screen, and underneath that is the thermistor that's measuring it. So I am going to also show a video of our project. So you can see on the breadboard and Arduino Uno, this is our project. We have our water level sensor, we have our ultrasonic sensor, and our thermistor for measurements. So we have two different programs. Our temperature sensor is always being ran, and we have for our dial, you can see that as we submerge our water depth sensor, the dial will move according to how deep the sensor is being put in. Uh, and if we go ahead and download the second program, this is controlling our ultrasonic sensor. It's showing to the right now. And that will now display on our servo, where if I hold something a distance away, such as this notebook, you can see that as it goes further away, it will go down on the scale, and if we move it closer, it goes upwards on the scale. So that demonstrates all three of our measurement systems, and now we will move to our calibration steps with Brian.
Alright, so we use different procedures to do the calibration of each system. For the temperature system, the way that we did it is we used that glass of water, heated it a bit, took a separate thermometer to get the true value of the temperature, and then used the Arduino kit's thermometer to get the measured temperature. Then we used some ice cubes, put it in there, let it cool. Then we took the new temperature system using both the thermometer and the Arduino, and we got 4 different points to create the calibration curve. For the contactless distance measurement system, Gavin used that notebook and held it at different points in space. He used a ruler to measure how far it actually was from the sensor, and then he used the sensor's output on the dial to go ahead and plot those points on the calibration curve. And for the water depth measurement system, he took that cup, used a ruler to measure the actual depth, and then he put in the sensor at that same distance to see the difference between the actual and measured values. And then the next slides, you can actually see the different calibration curves that we got. One for temperature, one for the contactless measurement system. And then the next slide, we also have it for the depth sensor.
The significance of this project can be found out in how Arduino can be applied across a wide range of applications. Is as an example, we were able to independently create a set of our experimental equipment with Arduino to measure 3 very different measurements. And using this, we also learned and applied a concept is for calculating the uncertainty and running regression analysis. Is an example of scenario in which this can be applied to is the construction of CubeSats, as in which I referenced. It's a group of researchers who were able to create a mock-up of CubeSat that utilize an Arduino processor in order to run experimental calculations on a magnetometer. So this concludes is our experiment.
All right.